Have you ever looked in the sky and see an aeroplane flying and wondered why they don't fall? And go ahead and ask yourself, doesn't gravity work on them as it does on other objects? It's quite confusing and ununderstandable. But this video explains why aeroplanes, jets, helicopters, and other air-based vehicles don't fall when they fly. But before I start, please subscribe and click the bell icon so you don't miss out on other educative and interesting videos. With that being said, let's dive right in. If you have ever watched a jet plane taking off or coming into land, the first thing you'll have noticed is the noise of the engines. Jet engines, which are long metal tubes burning a continuous rush of fuel and air, are far noisier and far more powerful than traditional propeller engines. You might think engines are the key to making a plane fly, but you'd be wrong. Things can fly quite happily without engines, as gliders, which are planes without engines, paper planes, and indeed gliding birds readily show us. If you're trying to understand how planes fly, you need to be clear about the difference between the engines and the wings and the different jobs they do. A plane's engines are designed to move it forward at high speed. That makes airflow rapidly over the wings, which throw the air down toward the ground, generating an upward force called lift that overcomes the plane's weight and holds it in the sky. So it's the engines that move a plane forward while the wings move it upward. Okay, so the wings are the key to making something fly. But how do they work? Most airplane wings have a curved upper surface and a flatter lower surface, making a cross-sectional shape called an airfoil. In a lot of science books and web pages, you will read an incorrect explanation of how an airfoil like this generates lift. It goes like this. When air rushes over the curved upper wing surface, it has to travel further than the air that passes underneath. So it has to go faster to cover more distance in the same time. According to a principle of aerodynamics called Bernoulli's law, fast-moving air is at lower pressure than slow-moving air. So the pressure above the wing is lower than the pressure below. And this creates the lift that powers the plane upward. Although, this explanation of how wings work is widely repeated, it's wrong. It gives the right answer, but for completely the wrong reasons. Think about it for a moment and you will see that, if it were true, acrobatic planes couldn't fly upside down. Flipping a plane over would produce downlift and send it crashing to the ground. Not only that, but it's perfectly possible to design planes with airfoils that are symmetrical, looking straight down the wing, and they still produce lift. For example, paper airplanes, and ones made from thin balsa wood, generate lift, even though they have flat wings. But the standard explanation of lift is problematic for another important reason as well. The air shooting over the wing doesn't have to stay in step with the air going underneath it. And nothing says it has to travel a bigger distance in the same time. Imagine two air molecules arriving at the front of the wing and separating. So one shoots up over the top and the other whistles straight under the bottom. There's no reason why those two molecules have to arrive at exactly the same time at the back end of the wing. They could meet up with other air molecules instead. This flaw in the standard explanation of an airfoil goes by the technical name of the equal transit theory. That's just a fancy name for the incorrect idea that the air stream splits apart at the front of the airfoil and meets up neatly again at the back. So what's the real explanation? As a curved airfoil wing flies through the sky, it deflects air and alters the air pressure above and below it. That's intuitively obvious. Think how it feels when you slowly walk through a swimming pool and feel the force of the water pushing against your body. Your body is diverting the flow of water as it pushes through it, and an airfoil wing does the same thing, much more dramatically because that's what it's designed to do. As a plane flies forward, the curved upper part of the wing lowers the air pressure directly above it. So it moves upwards. Why does this happen? As air flows over the curved upper surface, its natural inclination is to move in a straight line. But the curve of the wing pulls it around and back down. For this reason, the air is effectively stretched out into a bigger volume. The same number of air molecules are forced to occupy more space, and this is what lowers its pressure. For exactly the opposite reason, the pressure of the air under the wing increases. The advancing wing squashes the air molecules in front of it into a smaller space. The difference in air pressure between the upper and lower surfaces causes a big difference in airspeed. The difference in speed, observed in actual wind tunnel experiments, is much bigger than you'd predict from the simple equal transit theory. So if our two air molecules separate at the front, The one going over the top arrives at the tail end of the wing much faster than the one going under the bottom, no matter when they arrive. Both of those molecules will be speeding downward. This helps to produce lift in a second important way. Hence, keeps the plane flying upwards without the plane falling. Now we can see that wings are devices designed to push air downwards. It's easy to understand why planes with flat or symmetrical wings or upside-down stunt planes can still safely fly. As long as the wings are creating a downward flow of air, the plane will experience an equal and opposite force lift that will keep it in the air. In other words, the upside-down pilot creates a particular angle of attack that generates just enough low pressure above the wing to keep the plane in the air. This is why planes fly without falling. Before you leave, remember to click the subscribe button and click the bell icon so you don't miss out on our interesting videos that are yet to come.
Thank you for watching. Do well to like and leave a comment. Remember to subscribe, don't forget the bell icon too.